All right, ladies and gentlemen, let's go ahead and finish up this last section, chapter 15.4. Again, we're going to be looking at more trig derivatives and some higher order derivatives. And we'll explain that as we go. So as we take a look, here's our ones that we're familiar with. We know sine of x, derivative of sine of x is cosine of x. Derivative of cosine is negative sine. And now we start running into some of the other ones. So the derivative of sine's buddy cosecant is the opposite of cosecant times cotangent. The derivative of cosine's buddy, secant, is secant tangent. And the derivative of tangent is secant squared, and derivative of cotangent is negative cosecant squared. So we're going to use those throughout this section, and we'll be taking a look. Here we go. Example number 1. I've got 5x secant of x. So as I take a look, I notice I've got an x here. So this reads 5x times the secant of x. So that means I've got to do my 1d2, 2d1. I got the product rule here. I got two functions. So anytime I have an x value, I've got to look at that as f of x. And this is a g of x. I got to look at two functions. So here we go. I've got 1d2 plus 2d1. I'll write that out for our notes. 1d2 plus 2d1. And here we go. I got my first function is 5x times the derivative of secant of x. So I look up here. There we go. We got secant tangent plus the second function, which is secant of x, and then times the derivative of 5x, which we know is 5. So I simplify that. And I'll write that in front. It's not x times 5, it's 5 secant of x. Okay. Now if I look, there is one little thing I can do. If I look at both of these terms, remember terms are separated by that plus sign. Both of these terms have a 5 and a secant of x. I can actually factor that out. And now that leaves me with a binomial inside. I've got x, tangent of x, and then plus 1. So that's our derivative there. Okay. So final answer is 5 secant of x and then times x tangent of x. All right, let's look at number 2. On number 2, I've got a quotient. So I got my high one and I got my low one. So as we take a look, I always like to write this out for notes. I got my low d high minus my high d low over low squared. Okay, so I take the low one, which is 2x, times the derivative of the high one. So I take the derivative of cosecant. So as I take a look, there we go. We got the opposite of cosecant, cotangent. Minus the high one, which is cosecant, times derivative of the low one, which is 2x. Derivative of 2x is just 2. And now that's all over 2x, and that's quantity squared. Make sure you square the 2 and the x, not just the x. Okay? So I do a little simplifying on top. This is now a negative 2x cosecant of x, cotangent of x. And then this is not 2 times x, that's negative 2 cosecant of x. You just put the 2 out in front. And 2 squared, we can simplify that. That's 4 and then x squared. Okay. Well, if I look on top, I've got some things I can do, kind of like what we did over here. We have a 2 and a cosecant, and both of these, we can factor that out. In fact, I'm going to factor out a negative 2 cosecant of x. And now that leaves me with x cotangent of x. And then what, plus 1? That way when I distribute, it gives me back up here. And now what we have is we got some monomials. We got one term that we can reduce on top and bottom. The 2 here and the 2 here will cancel, reduce, and we end up with our final answer. I get the opposite of cosecant times x cotangent plus 1 all over 2x squared. Okay, so not too bad. Last but not least on this page, I take a look. I've got f of x is 3x squared minus cotangent of x. This is, again, not a product. These are two separate terms. So I just got to find the derivative of negative 3x squared, and I got to find the derivative of negative cotangent of x. If there was an x in front or some kind of term with an x in it in front of the cotangent, then I'd have to use a product rule, but that's not the case here. So all we got to do is find the derivative of 3x squared. So 2 times 3 is 6, and then subtract 1. That's 6x. And now I got to find the derivative of cotangent. So I go up there, I look at my sheet, the derivative of cotangent is negative cosecant squared. Go ahead and multiply the negatives together, makes a positive. So I end up with 6x plus cosecant squared of x. There's nothing else I can do to simplify that, so that is what it is. Okay. So our last goal for today is looking for higher order derivatives. So if I flip it on over, this will be pretty easy for most of you guys. Here's some notation here. So we have our y is our function. So y, which is f of x, that's our normal function. And then we're going to find the first derivative. That's what we've been doing up to this point. Okay. Well, now we're going to find the derivative of the derivative. So we're going to find the second derivative. So we use little double tick marks to denote that it is the second derivative. Or instead of dy dx, we got d squared y and dx squared. Okay, where you'll see that notation. And then the third derivative is the derivative of the second. We use 3 tick marks. And then after that, we just start using the number 4, or you can use Roman numerals, whatever you prefer. I usually just use numbers. Okay. Now, when we're looking at this in terms of physics, the exciting thing is usually we start with that position function. And then we take the derivative of the position, how your change is happening of where you're at, and that's velocity. That's your first derivative. So we have velocity here that we've seen in physics. That's our first derivative. And then the change in your velocity is your acceleration. That's the second derivative of your position function. And then the derivative of that is called the jerk. And we'll not get too much in depth in that. And after that, we just have the fourth derivative. So in terms of physics, these all are related. The position function, his derivative is velocity, and the derivative of velocity is acceleration, and the last one is jerk. Your physics teacher can talk to you guys about that. All right, so example number 4 asks us to find the second and fourth derivatives of our function. The way this is set up, I would probably just rewrite it. So it's 2 minus 2x to the negative first. That's our function. And now what I'm going to do is I'm going to go through and find the derivative of that. So the derivative of 2 is 0. And the derivative of this one, I'm going to bring my power down. Negative 1 times negative 2 is 2. And then subtract 1. Now that's negative 2. And I could simplify that if I want, but I'm not going to do that quite yet, because I really want the second derivative. We'll go up to the first derivative and take the derivative of that. I'm going to take this negative 2 down and multiply. Negative 2 times 2 is negative 4, and then subtract 1. Okay. Now that is one of the answers I want. Make sure you simplify that. So your final answer for the second derivative is just negative 4 over x cubed. Again, if it's a negative exponent, uptown, downtown, shoot it downtown and make it positive. Well, we still need the fourth derivative. Well, go ahead and find the third derivative. Again, go ahead and multiply. Negative 3 times negative 4 is 12. X to the negative fourth. And then do it one more time to find the fourth derivative. Take negative 4 times 12 is negative 48. And then x to the negative fifth. Again, uptown, downtown for that answer. For the fourth derivative, we would get negative 48 over x to the fifth. Okay, so there's my second derivative simplified. There's my fourth. So pretty easy. Just go and find the derivative of each. All right, last but not least, we have example number 5. It says find the equation of the tangent line to the graph of the function at the indicated point. In this case, we give f of x equals x secant of x at 0, 0. Now again, we've got an x value that has to be our first function, and then secant of x is our second function. So when you do your derivative, again, looking for the slope of the tangent line, we have to do 1d2 plus 2d1. So again, I take x times the derivative of secant of x. If you need to, look in the front. The derivative of secant of x is just secant of x tangent of x. And then plus 2d1, so 2 is again secant of x. And then times the derivative of x, which is just 1. Okay. So I can simplify that a little bit. I get x secant of x, tangent of x, just secant of x. And now to kind of make it a little nicer, I could factor out a secant of x. And that leaves me with x tangent of x, and then plus 1. I factor that out. Okay. Well, if I'm looking for the tangent line, I got to find the slope at 0. So I'll go ahead and plug in 0 here. And we got to figure out what the secant of 0 is. And then 0 times the tangent of 0 plus 1. Okay, so we can go off to the side. 0 is right here. 0, 1, 0. Cosine is 1, so secant, which is cosine's buddy, 1 over cosine is 1 over 1. We end up with 1 there for secant. 0 times tangent is 0, and then plus 1. So we get 1 times 1, which is just 1. Okay, so now I'm ready for my tangent line. I've got y minus y1 equals m, my slope, and then x minus x1. Well, the coordinate point I have here is x1, y1. I can plug that in. And then my slope at 0, 0 is 1. So final answer, y equals x. Okay. All right, ladies and gentlemen, that gives you the basic idea of higher order derivatives and then our new 4 trig functions. We actually saw a few of those in some of our homeworks where we asked you to find the derivative of sine over cosine or cosine over sine. And when you found the derivative of sine over cosine, you ended up with this one. And when you did the derivative of cosine over sine, you actually ended up with this one. So it works out perfect. Okay. All right. If you guys have questions, I'll be back the next day. Talk to you guys later.